This is my version of a sextant. Normally what you would do is instead of having this plastic thing, you'd tie a string with a lead weight on it. And then you can just look right down here. And then that lead weight would hang, and then you find your angles, and you'd find your angle that way. So this is a very simple version of a sextant. I can use this with a string and a lead weight. I can go, how tall is that tree? Well, I can measure the angle and measure the distance to the tree, and using Trig, I can find out how tall that tree is. So that's what we're going to kind of look at today a little bit before moving on. This one's short because we need to learn two different things. We need to learn angle of elevation. Okay. And so we're going to look at that exact tree problem and see how that works. And I'm going to draw a beautiful tree, although I don't have the color green. So it's fall though, right? So I'll make it fall colors. There we go. Even though an evergreen tree, because that's kind of an evergreen. All right, I don't know how tall this tree is, but I really want to know if it's going to smush this house right here. This is just a poor drawing. I'm going to stand right here. And I'm going to have anybody ever seen those little sticks with a wheel on it to measure long distances? Yeah. Okay, that's probably what I would use here. And so I'm going to say that this is 45 feet with that tool. 45. All right, and then I'm going to look at the top of the tree here. I'm going to look at the top of the tree here, and I'm going to say that's exactly 59 degrees with my little tool. And I can use this tool, like I said, with a string and find 59 degrees. And I can calculate the height of the tree. Okay? First thing you need to know is I'm not lying on the ground like a little bug. I'm standing 6 foot tall, right? So the first 6 feet of the tree are free. So I'm going to determine the feet above, because a 6 foot tree would be no angle at all. I'd be staring right at the top of it, right? So let's go ahead and see if this is going to smush this house. This house is 45 feet away. Which tool would I use? And by tool, I mean SOHCAHTOA. Well, let's label it. The tree would be opposite. I put an H because we're looking for the height of the tree, but it's the opposite. The ground would be adjacent. And then my sight line would be the hypotenuse. And this right here would be the angle of elevation, because I'm kind of looking up, aren't I? So what tool would I use? I have a variable here and a number here. Tangent, because SOHCAHTOA. I have an A and I have an O, right? Which one has an A and an O? TOA. That's what you got to study for the test, for big time. That's the hardest part. So what would that be? Opposite over adjacent, so that is tangent 59. Opposite is H. Adjacent is 45. Solve. Cross multiply. 45 times tangent 59 is going to equal my H. So what's H equal? So 45 times tangent 59 equals 74.89? Sure. 74.9 feet. What's it going to do to my house if I cut this wrong? It's going to crush the house, right? Okay, so you're probably going to need to do something different so you don't kill your house. This would be an example of using angle of elevation to determine the height of something to figure out more. In real life, what happens if your tree is like this and it's going to fall and hit your house? This guy's going to charge more money because this guy's going to have to make sure it has insurance, and he's going to have to take extra skill to make it fall a different way. If your house was like 100 feet away from this tree, you could just cut it down and it doesn't matter, right? You can't hurt anything. So that's part of what that is. So that's angle of elevation. We're also going to have the opposite because we have to do that in math. We always have to have the opposite. And we're going to have angle of, what do we think it is? Angle of depression. Don't we have to add 6 feet? You are correct. So the actual height of the tree would be 80.9 feet. I'm glad you brought that up. Either way, it's still going to crush my house. All right, angle of depression. Okay. I'll just do the example they have here. All right, we're going to have a little skier here. Okay. We want to know how far this skier is going to go. We want to know how far this slope is. Okay. We know that the skier, because it's really easy to tell how high you are up on a mountain because we have altimeters, right? Some people's watches have that. Some people's phones have an altimeter. This is 1,200 feet at the base, and it is, it is 1,200 feet higher than the base at the end of this slope. Okay? We're going to use this. This is 21 degrees angle of depression. So basically, I'm looking down, right? How would we find this? Let's see. I got opposite. I got hypotenuse.
The angle is 21?
It is 21, yeah. Hypotenuse, and this would be adjacent. So I heard the correct answer that sine involves opposite of hypotenuse. So this would be set up like this. Sine 21 equals opposite over hypotenuse. Okay, this one, we do the cross multiplication, but we do what I call the chutes and ladders, where we basically just take this guy and switch places. Okay, because I want the x by itself anyways. This saves me a step. And so, unfortunately, I'm kind of out of room, but I'm going to cheat and pretend like I have more paper. And write down here. So this would end up being x equals sine over 21. Nope, that's wrong. That's lies. 1,200 over sine of 21. And you just put that in, and you should get a reasonable number.
3,348.5.
Well, it has to be longer than this, doesn't it? It has to be longer than this because it's the hypotenuse. So,
3,348.5.
okay, so that's basically what it is if we're rounded to one decimal place, which we usually will. Okay, probably in real life, if you're making a sign about how long this is, you'd probably round it, right? Because no one wants to do decimals when they're skiing. But that's okay. That's okay. So that's basically how that works. Angle of depression, angle of, and this is basically, these are what you do real life, and you'd use a tool similar to this, or a more complicated tool to determine that angle to figure things out. Okay? And clearly, if you were doing this, and I just stole this from the book, if you were doing this, but instead of doing a ski, you were making stairs. You would need a tool to determine how long you're going to build those stairs for, right? And stairs cost money. So you need to figure out, by standing up here to go there, you need to figure out how much to charge the customer to build the stairs. And that's how they do it. You don't actually have people just measuring everything. You usually have one person that's smart, and they take a couple measurements with tools, and he stands there and does all the work. All right, that's that. I just need to go over those words. We didn't have time to do it yesterday. Let's do the last little bit of the basic trig before we do anything advanced. And so this will be 9.6. And this is going to be basically inverse trig ratios, which we don't know about. And solving, this is the whole purpose of what we're doing, solving right triangles. You don't see it at all. Okay, inverse trig ratios and solving right triangles. So we're going to talk about inverse trig ratios. Okay? So these are how you write your inverse trig ratios.
Can you put it back on the board?
Is it not on the board?
No.
I keep scooting it. Because one, it's on a piece of floating paper. So this is how you would write them. Okay, what did I add to them to make them the inverse? Okay. Okay, and this is what you need to know. To solve a side, I wrote sine, and then I added a D. A side, to solve a side, I'm going to use this. Okay, we already know how to use those, right? To solve an angle, I'm going to use this. This is something to study. Okay. Side, you use the regular ratios. Angle, you use the inverse. Okay. And basically that is it. And so let's go ahead and just look at a sample problem, and I want to figure out what the angles of this triangle is. I want to know what all the angles of this triangle. Again, I'm going to use a Pythagorean triple just to make our work easier. I want to know what angle A is. I want to know what angle B is. How am I going to do that? Well, let's start with angle A. For angle A, this would be opposite. This would be adjacent. This would be hypotenuse. Okay? So I'm going to say this. The tangent of, I don't know, A is going to equal what? Opposite over adjacent, yes? We did this before, yes? But I don't want, I did this before, but I want to know what A is, not what the tangent of A is. And so in all of algebra, everything has an inverse. Everything has an opposite operation. So the opposite of tangent would be inverse tangent, right? So basically what I'm going to do is I am going to do the inverse tangent to both sides. You are probably not going to write this step all the time, but you do need to start with this and definitely do this. Okay. So basically the tangent cancels each other out. That's the purpose of inverse operations. And then all you do in this is you need to learn how to do the calculator. So notice on here, and I'm going to get real close, and this is on all scientific calculators. Notice on here that in green, that's a -1, -1, -1. So to do the inverse of anything, I just hit second. and inverse tangent. And I should get second inverse tangent. And then I just type in that fraction, right? 5, 12, and what am I going to get? Okay, 22.6. So angle A is what? Okay. Now let me unzoom. Okay, and do I have to do trig to find B? Or can I just do 180 minus 90 minus 22.6? Am I allowed to do that? So a lot of times you do trig to start your problem, but you don't end your problem with trig. Just like in algebra, the further you go through a problem, the easier it gets. So that's inverse sines. Okay, so the biggest core concept here is solving right triangles. That means to solve a triangle, means to find all sides and all angles. Okay, find all sides and all angles. So let's do another triangle and let's solve this. So I'm going to give you this. Let's solve all sides and all angles. And this is ultimately what we've been working towards. What makes this a good problem is it involves problem solving, where you have to come up with a strategy. Okay. The nice thing, what you're going to see with all of these triangles to make it easier on you, is they're basically going to take this pattern to help you out. We're going to have capital A, capital B, capital C. Opposite of capital A, they're going to have little a. Opposite of capital C, they're going to have little c. Opposite of capital B, they'll have little b.
What is the hypotenuse on the first one? Is that C?
That's c. Yeah, because of the Pythagorean theorem, right? A squared plus b squared equals c squared. And so that's where that's coming from. But just know that the side A is opposite of angle A, the side B is opposite of angle B, and the side C is opposite of angle C. C is always going to be your 90 degree, and C is always going to be your hypotenuse. So we need to solve this. Where would we want to start to solve this? We could start all kinds of places. Okay? All you need is 2 bits of information and it to be a right triangle, and you can solve all of them. Are you allowed to use the Pythagorean theorem to solve for C? Yes. That's one of your tools, yes. Do you have to solve for C first? No. Can you start solving for A and B? Yes. So you do what you want to do on this, and let's see if we get the right answers. Me personally, I do the Pythagorean theorem just because it's easier to solve for C. Okay, C equals radical 13. I don't really want to do that. Let's see. We're going to have to round our answer. So, because this is kind of supposed to be real life. So the first part is exact. This is real life. So we're going to have to round this to probably Well, if you don't know how to round it, you push this button. By this button. So that 3.6 works. Okay, let's make sure it makes sense before I continue. Is 3.6 the longest side of this triangle? Then we're okay. All right, I got C. C equals 3.6. Great. I'll label it here. That's fine. Now I need A or B. Sure. Let's do A. We'll do A first. Okay, A. I don't want to use this because it's rounded. If I use a rounded number, it's going to make my problem maybe less accurate. I'm going to use these two because they're not rounded. So working from A, this would be opposite. This would be adjacent. And this would be the hypotenuse. I don't want to use the hypotenuse. I want to use opposite and adjacent. Which tool is that? It is tangent. So tangent of A is going to equal opposite over adjacent. What's the one step? A equals tangent inverse 3, 2. You put that in the calculator, you're going to get A. What is A? 36.3 degrees. Is that true? Okay. How can I find the last angle? So if I have to subtract 90 every time, can I skip that step and just do 90 divided by, 90 minus 36.3? Is that okay? And that's going to be 53.7? Yes, question.
I put that into my calculator, the inverse of 10 and then 3 halves, and I got 56.3.
Okay. Well, then
Me too.
I was just going off what you guys said.
I said 56.3.
Well, then you should have corrected me.
I was really confused.
So don't be confused. I was going off what I heard them, and so if I don't write what I hear, tell me, because I wasn't going to do it if you guys did it. So then that messes up B too, huh? So 90 minus 56.3. And so this would be 33.7. Okay, we solved that triangle. No big deal, right? Okay, are there going to be harder triangles to solve? Yeah. They're probably going to be harder triangles to solve. Okay? And so you just kind of have to figure out which tool you want to use and how to solve it. Let's go ahead and look at your book because I don't want you to get confused. I don't like to go over the easy problems very much because you don't need help on them, but yet sometimes we need to be reminded to do the easy problems correctly. This is on page 455.
When are we going to grade our
When we're finished or not finished. So, all right, here we go with this. Here. Just wait. So here we go. The cosine of angle 4/5. It just says determine which two acute angles have the given trigonometric ratio. So you're basically trying to do what we did backwards. So in this case, cosine of what angle would be 4/5? Of course, you'd have to reduce these numbers because 8 over 10 would be 4/5, right? So what would cause an 8 over 10 to happen for cosine? Okay, that's all that is, right? Don't make that hard. Definitely don't make 7 hard. In exercise 7 through 12, be an acute angle. Use the calculator to approximate the nearest measure to the nearest tenth of a degree. Okay? This is what it literally wants you to do. And people struggle with this on the test, and I don't know why, and I don't know how to stop it. They want you to do, okay, let's look at this one. I'm going to type it in. Done. Is that all I have to do? All right. Solve the right triangle, round the decimal, answer to the nearest tenth. That's what we just went over. That's our assignment.